At the very end, we talked about how these two lines not only intersected, but they intersected in a right angle pattern. Remember that? So what we're going to do with this is draw a little conclusion. Do you guys remember we did finish with this? We talked about this. Do you guys remember the slopes of parallel lines relationship? They are the same. Yeah, they are equal to each other. So if the slopes of parallel lines are equal or the same, then, when we look at perpendicular lines, we started to identify some slopes, and we noticed that these two numbers right here, the 3/5 and the 5/3, they were different, right? And so if slopes are different, then the lines are going to be non-parallel. But these two slopes, we didn't get to this, these two slopes have kind of a special relationship. How would you describe the relationship between negative 3/5 and 5/3? Will? They are opposite and?
Right angle.
Yeah, that's the lines are right angles, but what about the numbers? The numbers are definitely opposite, right? Because one of them is positive, the other one's negative. But there's more to it than that, right? There's one more thing. What is it, Kendall?
Reciprocal.
Reciprocal. So the slopes of perpendicular lines are opposite reciprocals. Okay, so those are the kind of the two big takeaways from this section. We want to remember that parallel lines have the same slope and that perpendicular lines have slopes that are opposite reciprocal. So opposite means the signs are different. Reciprocal means that they are flips of each other, like vertical flips of fractions of each other. So that's your big takeaway. Make sure you get that down. And we're going to do one more example with this. We're actually going to skip the very next example, and we will do the last example here together this morning before we do slope-intercept form. We good? Okay, cool. So here it is. We're going to skip this one. We're not going to do number 8. Don't worry about it. I'm not going to put that sort of thing on a quiz or a test right now. But this one right here, I do want to make sure that we know how to do this. And I don't know if we're going to, I think we'll probably just do this one together. So it says, determine whether the line that passes through 1, 4, and 5, -2, and the line that passes through 6, 2, and 9, 7 are parallel, perpendicular, or neither. So let me ask you guys this first. How many lines are described in this question?
2.
2 different lines, right? Yeah, you're right. So the first line goes through this point and this point, and the second line goes through this point and this point. We're talking about 2 different lines, a red one and a green one, I'm going to call them. And the question, well, what is the question? What are we supposed to figure out here?
Are they parallel?
Are they parallel, perpendicular, or neither? Okay, so if we are trying to decide if they're parallel, perpendicular, or neither, what should we start to think about comparing? I heard it, I thought. Slopes. Yeah, didn't we just say a second ago that parallel lines have equal slopes and perpendicular lines have opposite reciprocal slopes? So we need to compare the slopes. So how can I figure out the slopes if all I have are points? What can I do?
So you would take, so the ones that are circled in red.
Yep.
You would do the y's, y2 minus y1 over x2 minus x1.
The slope
Those
formula.
2.
Okay.
And then you would do the same thing for the other 2, and if they get the same slope.
And then compare, right?
Yeah.
Yeah. Does that make sense what Jake said? It's a good strategy. Let's find the slope between the red points first. So I'm going to call this point number 2 and this point number 1. Okay, so if that's my point number 2 and my point number 1, I'm going to write M equals, what would be my y2? Sam? It would be -2. This is the second y, right?
Yeah.
You are correct. So -2 minus, what would then have to be my y1? 4. Good. All right. So if that's my y2 minus y1, what would have to be my x2? 5. Good. Minus my x1, which would then have to be 1. Okay, awesome. So now we got to do a little arithmetic here. What is -2 minus 4? -6. And of course, 5 minus 1 is 4. So I'm getting -6 fourths. I am going to reduce this just so I can compare as easily as possible. How does this reduce?
Negative by 2, so 3 over 2.
Yep. Negative 3 over 2. So that right there, that is the slope of my red line. And now, as Jake suggested, we're going to try to find the slope of the green line. And so I'm going to call this point number 2 and this point number 1. Again, to be consistent, Cole, what would be my y2?
7.
That is correct. And Emily, we're going to go 7 minus 2. Very good. So that's my y2 minus my y1. So if that's my y2 minus y1, Sadie, what would be my x2?
9
And then 9 minus 6 would be minus my x minus 1. Good job. Okay, so as we evaluate this, what do we get? 7 minus 2 is 5 over 3. Okay, so I compare those two slopes. Are those the same slope? Definitely not. Are they opposite reciprocals? They are definitely opposite, aren't they? But they're not reciprocals, right? So the answer to this one would be neither. Neither parallel nor perpendicular. That would be the conclusion we'd have to draw there. Okay, Grace, go ahead.
So couldn't you just graph these two?
So graphing is kind of tough. I mean, I don't know if you noticed, like when I was trying my best with the graphs before, as hard as I tried to make the lines look parallel, it was hard to make them perfect. And same thing with the perpendicular. I mean, they were like fairly close, but it's really hard with a graph to judge this. Does it make sense? I think a graph would be an okay indicator, but I mean, honestly, it's hard to tell if a line is like half a degree off. You know, like if one slope was like, I don't know, 5 30-seconds and the other one was 6 30-seconds, it's going to be really hard to tell the difference. So I would use this sort of thing to be for sure. All right, do you guys have any questions? Okay, so we are going to now do what I think a lot of you have heard of or done in the past, and that is the slope-intercept form of a line. Remember, we're just skipping number 8. We're not going to worry about that one. Not anything that I'm going to quiz you on or anything like that. Okay, so this is section 3.5, slope-intercept form of a line. So how many of you have seen this before? I'm just kind of curious. Y equals mx plus b. So decent number. Yeah, it's definitely the majority of you have seen this. Okay, this is the most common thing you see in middle school when you go to trying to graph a line. But I think there are some very significant misconceptions that I see coming through. For instance, when we look at this y equals mx plus b, if I were to say, there's your slope-intercept form, can anyone tell me what the slope is? What would you say? So there's the misconception. It's either m or it's mx, right? The slope is actually m. The slope will not include the x. So let's talk about what this is, or how we would identify this. The slope is definitely the number that is attached to the x. It just does not include the x. If your slope varies, you actually have a curvy graph, and these are lines, right? So your slope would simply be m, and your y-intercept is b. So let's test this out a little bit. I'm just going to give you some random examples that are already in slope-intercept form. So let's try this one right here. What if I gave you y equals 2/3 x plus 9? Can you guys tell me what the y-intercept would be for that one? 9. What's the slope? 2/3. 2/3. Does that make sense? All right, so you can have other varieties of this. You could have y equals negative 4x minus 1/9. Okay, so in this case, what is the slope?
-4.
Negative 4 is the slope. What's the y-intercept?
-1.
-1/9. So this is a common situation where people every now and then will get this mixed up because they see the y-intercept as a fraction, but don't we often see the slope as a fraction? So it's not that you're looking for a fraction for the slope, you're looking for the coefficient on the x. That's what the slope is. Okay, so your y-intercept would be -1/9, and your slope would be -4. Okay, there's at least one more I want to throw at you guys and see how you do. What if I said y equals 7 minus 2/5 x? What is the y-intercept?
7.
7, right? And what's the slope? -2/5. Now this is where people get confused because they're used to the slope coming first, right? They're like, no, Mr. Anderson, it's y equals mx plus b, and the first thing I see up there is a 7, so that must be the slope. Be really careful, that's not it. The coefficient on the x is the slope, and then the constant is the y-intercept. So we have to be super careful that we're not just looking for the first number we see or the second number we see. The slope is the coefficient on the x, the y-intercept is the constant. You guys have any questions? Or is there anybody who would like to do a few more like that, where I just kind of quiz you? You want to do some more like that? I'll do a couple more. So let me erase these. We're trying to make this fit the y equals mx plus b pattern. Okay, so let's go with this. Let's go y equals negative 2/3 plus 5x. So look carefully, don't blurt anything out, just think it over real quick. Okay, what do you guys think the slope is for this one? What do you think? Go ahead, Sadie.
5,
Close, really close.
just 5.
Just 5, yeah. So the slope of a line is always a constant. So if you're about to say the slope of the line is like something x, probably should just pull the x off, and you'll probably be right. Okay, so the slope is 5, and the y-intercept is?
Negative 2/3.
Negative 2/3. Negative 2/3. That makes sense? Okay, let's try this one here. Can I just mess with you a little bit?
Yeah.
We'll see. We'll see how you do. Y equals, I don't know, 1/4 plus 8x minus 2x. Think it over. Let's give everybody a chance to think this one over. Okay, so Will, you just say what you've identified.
Well, wouldn't that slope be just 6 because you combine?
Do you guys see the like terms?
Mm-hmm.
So I agree. Slope is 6. Page,
I was going to say,
I agree. And then that means the 1/4 would have to be what?
the y.
The y-intercept. Okay. Is that good enough? There's like, when I said you want to do some more of these, there's definitely at least half dozen of you that are like, yeah, I'd like to do more of those. Would you like to do some more? Or is that one more? Sure. Okay. Okay, let's say, I'll keep it relatively vanilla here. What if we had y equals 13/5 x minus 8? Y equals 13/5 x minus 8. Okay, Hosanna, what do you see? What can you identify? Just either of the two, slope or y-intercept. You don't know? Oh, goodness. Okay, so let's look this over. Hosanna, let me help you out. What we would want to do here is we're looking for like numbers that are in the same relative location. So if I look at this right here, y equals mx plus b, we're saying that the slope is m. And I would say at this point, we don't want to say y is the slope m. We just want to say, okay, this is slope-intercept form, the slope is m, and the y-intercept is b. So as I look over here at this one, which number appears to be in the place of the m? Hosanna, do you see how this is in the place of the m? Because you've got mx, and this is 13/5 x. So I'd say slope is 13/5, right? Okay. And then I've got the b over here. Well, the b is the constant. And I look over here, well, look at that, -8. That's the constant. And so I'd say slope is 13/5, y-intercept is -8. Does that make more sense? Okay. Any questions? I kind of don't want to move forward until I feel like everybody's got this. So I'll just be patient. Just because it's not going to make any sense. Minus 3y is equal to 4. Looking at that right there, is that currently in slope-intercept form?
No.
No.
Why not? How can we identify that it is definitely not, Victoria?
Because the y isn't by itself.
And that's the key feature, right? So you know that you're in slope-intercept form when the y is by itself. So in order for us to judge what the slope is and what the y-intercept is, we need to have the y by itself. So this is where all of our work with the last chapter and being able to solve for various things is going to come in really handy. So let's take a look at how to do this. What would you guys suggest we do in order to get the y by itself? I think there's one very clear first step that's probably best. What would you guys do? We're trying to get the y by itself. Sadie?
Plus negative 9x to 4, like this side is 4, plus minus.
Yeah, so we would add 9x to both sides, right? Yeah, exactly. So I will go plus 9x to both sides. And Sadie, you said it really well. You said, and so on the other side you'd get like 4 plus 9x, because those are unlike terms. And so that's exactly what we'd get. So we'd say negative 3y equals 4 plus 9x. All right, so the y is supposed to be by itself, yet it's not. It's better. We need to do what, Garrett?
Divide by -3.
That's exactly right. And here's how I would prefer you do it at this point. I kind of hinted at this last chapter. I would rather you guys divide each term by -3 as far as the notation goes. This will make your finding of the slope and the y-intercept a lot easier. Okay, so let's simplify this a little bit. Y equals 4 over -3 does not really simplify, so that would be -4/3. But what is positive 9 over a -3? -3, yeah, they reduce it down to -3. So minus 3x. Okay. So now this is in slope-intercept form. How do I know that it is in slope-intercept form? Well, okay, it's mx plus b equals y, right? The y is all by itself. That's how I know it's in slope-intercept form. And now we can identify the slope and the y-intercept. Paige, your question?
Wouldn't 9 divided by -3 be positive 3?
No, positive divided by a negative is a negative. Just like a positive times a negative is a negative. Are you thinking of a negative divided by a negative? Maybe? A negative divided by a negative is a positive,
Okay.
but a positive divided by a negative or a negative divided by a positive is a negative. Was there another question? No? Okay. Based on this, Avery, can you tell us what the slope is? Slope is -3. How did you identify that?
It's simply the x.
Yeah, number attached to the x. I agree. So whatever is attached to the x there, the coefficient on the x, that's the slope. Therefore, Hosanna, the y-intercept would have to be?
-4/3.
That's correct. Does that make sense? Okay. Let's do this. I'm going to call it somewhat of an audible here. Let's do this at the board. Did really well. Okay. Number 2 says write the slope-intercept equation of the line that has a slope of -5/4 and a y-intercept of 0,6. Okay. So this is basically asking us to do the. Listen, please. Hey, gentlemen. This is basically asking us to do the opposite of what we just did, right? So before I gave you an equation. And I said, let's figure out what the y-intercept and the slope would be. This time, I'm not giving you an equation at all. I'm giving you the y-intercept and the slope and asking what would the equation be. So let me show you this one, and I think maybe we'll go to the board with this one as well once we've got this one down. Let's remember what slope-intercept form is first, right? It's y equals what? mx plus b. And remind me, what does the b stand for? The y-intercept, and the m stands for the slope. So I am told that the slope is -5/4. So what I would do to write the equation of this line is I would replace the m with -5/4. So it'd be -5/4 x. And then the b is the y-intercept. And so I'm going to replace the b with the y-coordinate of the y-intercept. So that would be +6. So y equals -5/4 x plus 6. That would be the equation of the line that has the slope, -5/4, and the y-intercept of 0,6. So you see how that was exactly the opposite of what we just did. I gave you the other information, and we had to go backwards to what we started with last time. So if you were not at the board just a second ago, please go to the board and let's try one like this. I'll just put this one off to the side. So same instructions, write the equation of the line. If slope is -3 and the y-intercept is 2/5. So please write the equation of the line has a slope of -3 and a y-intercept of -2/5. This was the answer. Like so. Okay, so let's move on. You guys are doing a nice job with this. Number 3, I've only got a couple more here. So this one. Guys, this is where we're going to start transitioning into graphing a little bit. This is kind of the point of this. Number 3 says, write the slope-intercept equation of the line that is graphed below. So this time I did not give you direct information. I didn't say the slope is this and the y-intercept is that. I've given you a graph of it though, right? And I've asked you to write the slope-intercept form of that line. So the two things we got to have in order to do this, I've got y equals mx plus b. I need to figure out what the m is, and I need to figure out what the b is. And in your opinion, what would you guys say is the easier of the two to figure out? What do you think, Cole?
The Y?
The m or the b?
Oh, the B.
The b, right? The y-intercept. We haven't really talked about exactly what the y-intercept is again in this context, but it's the same y-intercept we talked about before. It's the place where the line crosses the y-axis, right? Mm-hmm. So if you look at this, and we want to assume nice integer numbers, where would you guys say that this line crosses the y-axis, Kendall?
At the 2.
At the 2, yeah. So right there, where I put that red dot, that appears at least, right, where this line crosses the y-axis. And so I would say that my b is going to be a 2. And I agree with you also that that's probably the easier of the two things to find, right? The y-intercept usually pretty easy. Finding the slope, a little bit tougher. What we need to do, we already found one point that's on the line, right? We found the y-intercept. We need to find another point that is for sure on the line. So let me just point to a couple of these points here. When you guys look at this point right here, does it look like that point is on the line?
No.
I would say it's not. So let's not worry about that one. What about this point right here? Is that point on the line? I would say not. How about that point right there? Does that appear to be on the line?
Yeah.
To the best of my abilities, my powers of observation, I would say that point is.
Wait,
On the
on
line.
like the checkered line?
Yeah.
Yeah, the red, you see the red line. I'm wondering if that point right there is actually on the line.
On what line?
The red line.
The,
The big red line on the graph.
if
But
it's
all
on
of
the
them
center
are.
line, like if it intersects the blue grid.
No, they're not. It's slightly off.
So, Grace, what I'm getting at is, use a different color. Do you see that point right there?
Yeah.
That point is 1,
Oh.
comma 1.
Yeah.
Is that point on our line?
No.
It's pretty darn close, isn't
Okay,
it?
I get it now.
It's pretty close, I'll give you that, but I don't think that it's actually on our line. This point right here is 1, comma 0. And again, that's fairly close to our line, but I don't think that that's on our line. This point down here that I am re-highlighting in blue, that point right there, which is 2, -1, I would say that that point is on our line. So I'm looking for 2 points that are on the line. Does that make sense?
Yeah.
Okay. Let me erase all these little extra points that I drew. And what we need to do now is we need to calculate the slope, right, the m. So we need to calculate the m, or the rise over run. You remember that definition of slope? We need to calculate the rise and the run. And so a lot of times people will use what's called like a slope triangle for this. So what I'm going to do is I'm going to draw a vertical, didn't want to do that. I'm going to do this. I'm going to draw a vertical line straight down from that upper point and a horizontal line over to that other point, making what I would call like a slope triangle, right? I'm basically looking for my rise and my run. So what would you say is the length of that line segment, Victoria? 3. And how about the length of that line segment right there? 2. Okay. So, yes, ma'am.
Wouldn't it be a negative?
Well, that's what we're going to talk about right now. Wouldn't it be fair to say that as I go from left to right, this line is dropping 3 and going to the right 2? And so that means the slope really has to be a negative slope. And I would say the most common way of handling that would be what Victoria suggested there, making it a negative 3, because we are dropping down 3 and going over to the right 2. So keep in mind that slope is rise over run. And so m would be the rise, which is negative 3, over the run, which is 2. So the equation of this line would then have to be y equals negative 3/2 x plus 2. What do you guys think? Graph okay? Okay. Do you have any questions? Okay, so I would say that number 4 is kind of like what we've been building up towards. So let's take a look at number 4. And I think there's only one after that. So let's just see how this goes. Number 4, yes, this will work out just fine. Okay, so number 4 says graph that using slope-intercept form. Now, we are not going to go fast through this. If you have a question, you need to let me know. Please do not suffer in silence. Talk to your table partner, talk to me. Let me know how this goes. If you need any help with anything. So we're going to take our time with this. Just kind of see where we end up on time. I think our class ends at 25. So let's kind of go with this for now. So right now, 5x plus 2y equals 6. Is that currently in slope-intercept form, or is it not in slope-intercept form? How do you know that it's not, Alec?
It's because the y is not by itself.
The what is not by itself?
Y.
The y. Keep paying attention. Thanks. All right, so the y is not by itself, so we need to get the y by itself before we can really do anything with this. So Gracie, what would you suggest? If we're trying to get the y by itself, what would you do first?
Subtract the 5 and the 6.
Close.
I'm subtracting.
Really close. So there we go. We subtract the whole term over. There we go. So we've got 5x plus 2y is equal to 6. And Gracie said we should subtract 5x from both sides, and she is totally right. So when we do that, of course, on the right side, we have unlike terms. And so we would get 2y equals 6 minus 5x. And then we need to get the y by itself. Still not by itself. Cooper, what would I need to do to get the y all by itself?
You'd have to divide by 2.
That's exactly what we need to do. So we do that, just like we did before, and we end up with y equals 3 minus 5/2 x. So I want to pause real briefly right there. Do you guys have any questions on that part? Okay, fair enough. So now we're going to try to transfer this over to a graph, and in order to do that, we need to identify our slope and our y-intercept. So I'm going to say B, which is my y-intercept. Can anybody identify what the B would be for this one? Ashley?
3.
It's the 3. You guys agree with her? I hope you do. She's definitely right. Because it's the constant, right? I know it comes first. But the number that's constant, the one that doesn't have an x, is always the y-intercept. Okay, so let's be really careful with this. Sam, what would the slope have to be if the y-intercept is 3? Negative 5 over 2 is right. Good. Okay. So we've identified our slope and our y-intercept, and we are now ready to graph. So I want to be really clear about how you can do this and also what I would expect from you guys on this. So here are your steps. I'll just write this off to the side. Step number 1 is plot the y-intercept. So as you guys accurately mentioned, the y-intercept is 3. And so I'm going to plot that first. So 1, 2, 3. There's my y-intercept. You guys all see that? Little blue dot up there at 0, 3. Okay. Step number 2 is to count off the slope. Now here's where some folks will get a little bit mixed up. Would it be fair to say that we know that 3, like the y-intercept of 3, isn't that point on the line? That's one of the points on the line, right? So when I count off my slope, what I'm going to do is I'm going to start at the y-intercept and do my rise-run routine with that slope. So I want to show you something. I'm going to switch colors on you. I'm going to show you one thing I do want you to show. Now the slope is negative 5/2. What that means is I need to go down 5 to the right 2 to get my next point. So I'm going to go down 1, 2, 3, 4, 5, and then right 1, 2. Do you see my little slope triangle that I'm kind of drawing here?
Yeah.
And at the end of that little slope triangle, I'm going to put my second point. Now, if you want to, you of course can continue counting the slope off. So you could start with that second point, and you could go down 1, 2, 3, 4, 5, and then right 2. And there's another little slope triangle. You put a point right there. You can actually also go backwards. Yeah, you can go the other way. So instead of going down 5 to the right 2, you could go up 1, 2, 3, 4, 5, and then left 2. Isn't that the same pattern? And you'd put a point at the end of that right there. And you can see that they all form that same nice linear pattern. So let me fill in this line real quick, and then I'll get some questions. There's my line. Actually, let me say one more thing, and then I'll get your question. So what do I expect on a quiz or a test? I want to see, of course, that you've got points plotted. You don't have to label the points with like 2, 7 and -3, 5. You don't need to label them like that. But what I do want to see is like a visible dot, right? Something where you've said, okay, the line is right here. I've put a point on the line. It's a pretty obvious dot. You can kind of see it on mine, like the dots kind of stand out a little bit. And I do want to see your slope triangles, at least one of them. I want to see where you've gone down 5, right 2, or up 5, left 2. I want to see you actually sketch those in. You could use a little dotted line, or they could just be like sort of a sketched in line there or whatever. But I do want to see those slope triangles, just signifying that you know how to count the slope off. Jake, your question.
My teacher was picky about this last year.
Sure.
Do you want us to extend the line throughout the entire graph?
I'm not too worried about that. I think it's important to put arrows on it, because arrows mean, of course, that it goes on forever. But, you know, you can see down here, there's like, I guess, a little gap. Maybe your teacher might have taken a half point off from my graph right there. Right? I circled it in green. There's a little gap there. I think that's what you're talking about.
Yeah, just like it's extended.
I'm not too worried about it. The arrows tell me that it goes on forever. So whether my graph is like plus minus tens or plus minus millions, the arrows, it's just going to keep going forever and ever. So I don't think I'm too concerned about that. Any other questions? Okay. So let's do our last one here. You'll get plenty of chances to practice this. We'll practice this some more as we go throughout our week. Okay, so I think we can do this one. This kind of goes, guys, this goes full circle back to where we started our class here. This says use slope-intercept form to help determine whether the graphs of these two lines are parallel, perpendicular, or neither. We answered a question like this earlier. So I've got two lines. This is going to be my blue line, and this is going to be my red line. So let's remember, if two lines are parallel, their slopes are the same. If lines are perpendicular, their slopes are, I've heard it, yeah, opposite and reciprocal. And then if it's neither of those, then they're neither parallel nor perpendicular. And in each case, we compare the slopes, right? What is the slope of my blue line? Do you guys see it right here?
3.
No.
2/3.
Remember, the slope is the coefficient on the x. So the slope is negative 2/3. Can we easily tell what the slope of the red line is?
No.
Not really. We need to put it into slope-intercept form, don't we? It's not there yet. How do we know that it's in slope-intercept form or not?
Because they don't need y.
Yeah, it needs to be solved for y. So let's take this red line real quick. Let's solve for y. Kendall, what would I do first if I was going to solve for y?
You would subtract 3x from both sides.
So that would give me negative 2y equals 14 minus 3x. Still don't have the y by itself. What would I need to do to get the y by itself finally in the end? Lana, do you know?
Oh, you divide by itself, divide everything by -2.
That's right. So dividing by negative 2, let's see how this works out. I would get y equals, what's 14 divided by negative 2? Negative 7. And then what is a negative over a negative?
Positive.
Positive.
Okay, so what is the slope of my red line?
32.
3 2s. Okay, 3 halves, right? So now let's compare the slopes. Are they the same?
Perpendicular.
They are not the same slope. Are the slopes opposite and reciprocal?
Yes.
Yes, they are, right? They're flipped and they're different signs. And that means that these two lines have the relationship of being perpendicular. That would be our final conclusion for that one. Okay, you guys have done extremely well, but I also know that by this time tomorrow, you might have forgotten some of this. And so after our quiz tomorrow, we'll go back over slope-intercept form again. So this is not on the quiz, by the way, right? You guys know that? It's up through 3-4. This was 3-5. So 3-1 to 3-4.
3-5 made more sense.
Good.